All right, let's jump right into this. Welcome to The Explainer. Today, I want you to literally step into the shoes of a CEO and their executive board. Consider this your urgent strategic briefing. As your chief sustainability officer, I'm here to lay out what is absolutely going to be the central conflict defining our next decade. We're talking about the massive collision between our aggressive mandate to adopt artificial intelligence and our very concrete 2030 corporate sustainability pledges. So let's dive in.
Here's the roadmap for our briefing today. We're going to cover the AI climate collision, the true cost of AI, the hardware supply squeeze, the twist where AI might actually be our savior, and finally, action versus climate theater.
Section 1. The AI climate collision. Growth meets net zero.
So here's the absolute high-stakes dilemma we have to solve. I need you to hold two potentially contradictory goals in your head right now. Can we practically chase this explosive AI boom while keeping our 2030 climate pledges actually credible to our investors and the public? It is a really tough balancing act.
Think of it like a giant corporate tug-of-war. On one side, our growth targets demand explosive AI integration. We're talking massive computing scale and a relentless push for new market capabilities. But on the exact opposite side, our climate commitments require deeply public, absolute, carbon-negative, and net zero goals by 2030. That means deep emission cuts and sustainable scaling. The very engine we're relying on for unprecedented growth is literally pulling in the exact opposite direction of our ESG promises.
To see just how real this is, we just need to look at the big hyperscalers. The very companies we're buying our cloud services from. Their AI demand exploded, and well, their emissions skyrocketed right alongside it. Take Microsoft. Their 2024 emissions went up roughly 23% from their 2020 baseline, purely driven by data center buildouts. And look at that second point. Microsoft's Scope 3, which is their value chain footprint, is now 97% of their total footprint. Meanwhile, Google's emissions are up 51% since 2019. It's actually forced them into this kind of awkward PR pivot where they now label their 2030 net zero goals as merely ambition-based. Yikes.
Section 2. The true cost of AI. Training, inference, and water.
Okay, so AI's energy consumption is basically split into two distinct phases. First up is training, building the model. This is your massive one-off bomb. Training GPT-3, for example, used over 1,200 megawatt hours and emitted around 550 tons of carbon dioxide equivalent. Huge, right? But then comes inference, actually using the model day to day. Now, each query only uses a tiny fraction of a phone charge, but here's the catch. As we deploy AI across our entire workforce, those billions of daily inference queries are going to cumulatively dwarf the training cost over the model's lifespan. This is the endless cumulative build that's going to quietly balloon our own Scope 3 emissions. And guys, it's not just about electricity. Consider this super visceral data point. Researchers estimate that a single 100-word AI prompt consumes about a 500 milliliter bottle of water just to cool the servers. Just imagine that water footprint as we scale our enterprise operations. That is a lot of plastic bottles in your head, right? So the crucial takeaway here is that AI's emissions depend entirely on the grid powering those data centers. And the grid is the real bottleneck. Near-term projections show that 40% of the massive new AI power demand globally, up to 2030, is still going to be met by fossil fuels like gas and coal. The exact same data center is low carbon on a clean grid and high carbon on a dirty one. It basically turns our technical IT procurement choices into direct carbon liabilities.
Section 3. The hardware supply squeeze. Shifting the burdens.
Because AI isn't just straining the power grid, it's heavily squeezing global hardware. Take a look at this. A standard 32GB DDR5 memory kit sat at about $95 in mid-2025. But estimates for 2026, they project that rocketing toward $575 to $600. Why? Because AI accelerators require specialized high-bandwidth memory, and they are absolutely devouring the world's supply.
So who actually pays for this AI boom? Well, we do. Memory makers have aggressively shifted their wafer capacity to high-margin AI servers. It's a total zero-sum game. Every wafer turned into AI memory is one denied to standard computers. The result? Major brands have bumped consumer PC prices by 15 to 20%. Laptops are facing up to $400 markups. Even mobile phones are seeing shrinkflation, giving you less memory, like 8 gigs instead of 12, for the exact same price. Ordinary buyers, including hospitals, schools, and our own enterprise IT budgets, are just getting crowded out and forced to absorb the cost of big tech's AI ambitions.
And the analysts at IDC hit the nail on the head. They call this a permanent reallocation of capacity, not a passing cycle.
We cannot just wait this out like some pandemic supply chain glitch. This is a structural market shift that we absolutely must plan our budgets around right now.
Section 4. The twist. AI as savior. Now, here is the crucial nuance in this whole briefing. AI isn't solely a carbon liability. In fact, it might actually be our most powerful tool for decarbonization. The International Energy Agency estimates that by 2035, the widespread use of AI could enable emissions cuts 3 to 5 times larger than the data center's own massive footprint. We're talking about using AI to balance power grids, integrate renewables, cut waste, and speed up materials discovery. There is massive net positive potential here.
But we have to be super careful not to fall into this trap, the rebound effect, also known as Jevons paradox. It basically states that doing a task more efficiently doesn't guarantee you'll use less energy overall. Actually, as AI gets cheaper and more efficient per query, our sheer volume of usage explodes, driving total energy consumption right back up. Celebrating per-task efficiency is completely useless if our overall appetite wipes out those gains.
So, as an executive board, the honest read requires us to hold both of these facts simultaneously. We have to refuse to pick just the scary or the soothing narrative. AI is a fast-rising corporate footprint, yes, but it is simultaneously a powerful tool to cut emissions. Data centers pose a massive local infrastructure strain, yet they'll remain a modest global electricity share of under 3% by 2030. We have to operate with both of these realities.
Section 5. Action versus Climate Theater. The rubric.
Moving forward, I highly advise that every single AI investment we make is strictly categorized using this exact scorecard. Does the investment create real value by actually cutting emissions and costs, like, say, negotiating renewable power deals? Or is it a necessary cost, representing real money spent on long-term resilience, like zero water cooling designs? Or is it just theater? Moves that manage the PR number rather than the actual emissions, like buying cheap avoidance offsets or quietly relabeling our hard targets as mere ambitions. Remember, a good manager moves the emissions, a weak one moves the number.
This builds into a super practical 3-step action plan to keep our growth engines running and our climate pledges intact. Number 1, acknowledge Scope 3. Track the AI services we buy because they land squarely in our value chain. Number 2, weigh the net effect. We have to meticulously measure if our specific enterprise AI implementations actually save more carbon than those billions of inference queries cost. And number 3, move the tons. Our focus has to be strictly on reducing absolute emissions, rejecting those intensity tricks and avoidance offsets.
Which brings us to the end of our briefing. I want to leave you, the board, with this final, provocative question to chew on before we authorize our next major strategic move. Is our AI demonstrably saving more than it burns, or are we just hoping it will? The numbers are out there, and the market is definitely going to be watching our footprint. Thank you for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.